In this section, we'll be looking at section 8.1b, which is the law of cosines, which is going to help us to solve triangles if the law of sines doesn't help. So if we are given two sides and the included angle, meaning the angle between those two sides, or if we are given all three side lengths, we will use the law of cosines. There are three different ways to write the law of cosines, but if you only want to learn one of them and redefine your variables, that's totally fine. So if we are given a triangle with angles and opposite sides as labeled in the picture, then a squared is equal to c squared plus b squared minus 2bc cosine of alpha. B squared is equal to a squared plus c squared minus 2ac cosine of beta. And c squared is equal to a squared plus b squared minus 2ab cosine of gamma. I'd like to note that both the law of sines and the law of cosines is on your formula sheet. The law of sines is up here. Just note that they use capital A instead of alpha for the angle. Same with the law of cosines. So here we have the two triangles that were on the very last slide of the law of sines, and we're going to try to solve them now. So taking a look at this where we have a side of 16, a side of 10, and the included angle 30 degrees, because it's between the two, I'm going to call this side C. That would make this angle gamma, or capital C if you're using the formula sheet. And then I'll just call this side A and this side B, which would put this as alpha and this as beta. So according to the law of cosines, the one angle I do know is angle gamma. So I'm going to use the equation that had angle gamma in it, and that was the last one. C squared is equal to a squared plus b squared minus 2ab cosine of angle gamma. I know A, I know B, and I know angle gamma. So let's plug all that in. C squared is equal to 16 squared plus 10 squared minus 2 times 16 times 10 times the cosine of 30 degrees. You might notice that this is similar to the Pythagorean theorem. In fact, the Pythagorean theorem is a very specific case of this, where your angle is 90 degrees. So that's kind of cool. But anyway, if we have 16 squared plus 10 squared minus 2 times 16 times 10 times the cosine of 30 degrees, that's c squared. So if I square root that answer, I get that c is equal to 8.8810. So I have my third side. If I know that this side is 8.8810, then I have a side and its corresponding angle. I can now use the law of sines. I'm going to find angle beta here using my law of sines. So the sine of angle beta over side B, which is 10, is equal to the sine of my 30 degrees, angle gamma, over side C, which is this 8.8810. If I multiply both sides by 10, I get the sine of angle beta is 10 sine of 30 degrees over the 8.8810. 10 sine of 30 degrees divided by 8.8810 gives, and then inverse sine that tells me that angle beta is 34.2635 degrees. Then I can find my angle alpha by taking 180 degrees minus the 30, that was angle gamma, minus the 34.2635, that was angle beta. and that gives me that angle alpha is 115.7365 degrees. I solve for my side C, my angle alpha, and my angle beta. So I have everything. Next up, I have this case where I have the 3 side lengths. So I'll just call this one A, this one B, this one C, just for funsies. That'll put this as angle alpha, this is angle beta, this is angle gamma. I guess it doesn't really matter which form to use. I will solve for, I guess, angle alpha first because it's the smallest. So I need the formula that has alpha in it. So that will be a squared equals b squared plus c squared minus 2bc cosine of angle alpha. So that'll be 5 squared is equal to 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of alpha. Let's do some algebra here. I have 5 squared. I want to subtract the 8 squared, and I want to subtract the 10 squared. So that tells me negative 139 is equal to, what is negative 2 times 8 times 10? Negative 160 times the cosine of alpha. If I do negative 139 divided by negative 160, I get that the cosine of alpha is that value. So if I inverse cosine it, I get that angle alpha is equal to 29.6863 degrees. And now that I have angle alpha, I can use my law of sines. Because the sine of angle alpha, which I just found, over side A, which is 5, is equal to the sine of angle beta over side B, which is 8. If I multiply both sides by 8, I get 8 times the sine of alpha, and we said alpha is 29.6863 degrees, all over 5 is equal to the sine of beta. So if I take my 8 sine of 29.6863 and divide it by 5, inverse sine that, I get that my angle beta is 52.4105 degrees. And that allows me to solve for angle gamma. Gamma is 180 minus what alpha is, minus what beta is. And 180 minus 29.6863 minus 52.4105 gives us that angle gamma is 97.9032 degrees. I solved for my 3 angles, so I've solved my triangle. So you may be asking yourself, how do I know when to use the law of sines and when to use the law of cosines? So here it kind of lays out when to use what. If you remember back to geometry, I'm going to try to use some notation that might help you remember. We use the law of sines if we are given 2 angles and the non-included side, so 2 angles and one of the sides not between them. We called this angle side back in geometry because as you go around the triangle, you know an angle and then an angle and then a side. We can also use the law of sines when we have 2 sides and the non-included angle. So 2 sides and an angle not between them. In geometry, we call this side-side angle. Now, back in geometry, your teacher probably would have yelled at you if you called this angle side-side, but honestly, it might be a little bit better to think of it as angle side-side because this was the ambiguous case where we had to check if we had one triangle, two triangles, or zero triangles. And that's problematic. So calling that the ask case, I'm okay with that, let's be honest. Then we have our law of cosines. We used that if we were given two sides and the included angle. So that one was side angle side. Or if we were given all three sides, which was side, side, side. Those are the cases of when to use the law of sines and when to use the law of cosines.